Yeah.
So what was this? Cosecant of arctangent?
Of x over root 2.
Cosecant of arctangent of x over root 2.
Mm-hmm.
Okay. So you probably drew some kind of picture like this.
Yeah.
Where you put x and root 2.
Yeah.
Okay. So just to be obnoxious, I'm going to do my unit circle picture.
Okay.
Which puts x over root 2 right here, and then a 1
Okay.
right there, right? So now cosecant of arctangent. Cosecant is 1 over sine. Okay. This thing, arctangent of x over root 2, is an angle. Okay. So labeling this thing as an angle is appropriate.
Okay.
Sometimes it's easy to lose sight of that fact, that this object right here is an angle and deserves to be labeled in the picture as an angle. Right? I mean, that's what cosecant sees.
Yeah.
Are angles. Okay, so what's next in the scheme?
You would have to find the length of the hypotenuse.
Okay, that's easy enough.
Okay.
Right. And then it's x over root 2 over root 1. So it's like, no, it's the other way. It's the reciprocal.
Right.
So it'll be this divided by that. Okay. Let's talk about domain and range of secant.
Okay.
Secant of theta. Domain and range. You tell me.
I'm not sure.
Okay, so remember in our unit circle picture, if I'm going to draw my tangent line
Right.
here, then secant of theta was this hypotenuse.
Right.
Right? So I'm drawing valid values for secant. Okay?
Okay.
And evidently the ones below the x-axis are to be interpreted negatively, I guess. No, that's not true. Secant is 1 over cosine. Right? So all of these are to be interpreted positively.
Okay.
And then if I go over here and I draw this tangent line and I draw all these are to be interpreted negatively. Okay, so maybe my little analogy is breaking down. But put it all together and we see that the invalid values for secant are here and here.
Yeah.
Right? So theta cannot be
Pi over 2.
Pi over 2 plus any multiple of pi. Right? And the range of values for secant is at its smallest. Right here. And then it gets bigger. And it gets bigger.
Right.
Right? So if I were to graph this, what would I do? I would say at 0, secant takes on the value 1. And at negative pi over 2 and positive pi over 2, secant evidently is shooting off to infinity.
Yeah.
Right? So I have asymptotic behavior.
Mm-hmm.
Right? Okay, so now the other half of that is if I'm continuing with the analogy, as soon as I cross over pi over 2, now secant is doing this kind of thing, right? It's like negative infinity all the way up to -1 and then all the way back down to negative infinity because we've decided to interpret all of these things as negative because if we don't, then our story breaks down. So at what, pi, secant is -1, right? Okay, so there we have one period of secant as graphed without appealing to cosine. Because secant is a founder of the unit circle.
Yeah,
all right?
we would graph it and we would graph cosine first.
Okay, yeah, but cosine is like the administrative assistant of you know, sine, tangent, and secant. They don't have co in front of them, right? Cosine is the assistant to sine. So it's just another way to think about it. And it also illustrates, like, really clearly why the range of secant is always bigger than 1. Because none of these hypotenuse ever get shorter than this one.
Yeah.
Okay? And then we've got this other thing about negative whatever. And of course, you know, I'm not telling you not to go in there and graph cosine and say to yourself, oh, look, you know, like, look, it works out.
Yeah.
You know, of course it does, right? But just knowing that, you know your history. Secant founded the unit circle.
Okay.
All right? Secant built the thing from the ground up, you know, and cosine comes in there and tries, you know, cosine comes in there and is like, I'm part of the formula for secant, and I'm part of the formula for tangent, right? And so, also, looking at all these lines and reading off their slopes, you can graph tangent, right? And then the I'll end with this. We can graph sine of theta, tangent of theta, and secant of theta, all by doing unit circle stuff, like sine of theta is the y-coordinate, secant of theta is the length of this hypotenuse, and tangent of theta, so I'll do it like this. Sine of theta, tangent of theta, secant of theta, right? So secant of theta is this, tangent of theta is this, and sine of theta is this.
Right.
Okay? Now, how do you know what cosine, cotangent, and cosecant are? Cosine of theta is sine of pi over 2 minus theta, and ditto for the others. Okay. The reason why we don't teach it this way is entirely a byproduct of textbooks. It's entirely because knowing things this way is not useful for answering 37 questions in a row in the homework.
Yeah.
Okay? But it's like understanding sine, tangent, and secant, according to this interpretation, sort of very clearly shows you why the range of secant is what it is, the range of tangent is what it is, and the range of sine is what it is. Likewise with the domains. Okay? All right. And then finally, like, if I want to do the cofunction stuff, I just, like, do this.
Yeah.
To the triangle. All right. And then I have all the cofunction stuff.
Okay.
Okay.